Today we will look into the dihybrid cross results using a Punnett square. This is useful primarily in genetics and identifying the phenotypes and genotypes of the different offspring. Phenotypic and genotypic ratios may also be determined using this process. A scientist crosses two pea plants that are heterozygous for plant height and flower color. Tall is dominant to short, and purple is dominant over white. The plant's height and flower color genes are unlinked. Solve for the genotypic and phenotypic ratios using a Punnett square. Show all work. So let's get started with this example. So one of the first things I like to do is define the variables or have a set of letters that we're going to use for our Punnett square. So we're going to have big T standing for tall, small t standing for short, big P standing for purple, and small p standing for white. So you're going to see our heterozygote, or the combination of the big T, small t, and big P, little p, is going to be this up at the top, and that'll be the genotype of the tall purple pea plant. So next up, we're going to start building our Punnett square, and when building our Punnett square, we need to keep in mind that each parent can produce 4 types of gametes due to their dihybrid nature. So you'll see that we now have our setup of the Punnett square, and so as there's pretty much, this is one of the best ways to set it up. You can have either the male or female either on the side or at the top. It doesn't really matter all that much for the dihybrid cross. And so next we'll get to the fun part of filling out the square. So here is the filled out Punnett square. You may have already done this, or if you're waiting to see it, here it is. So we see that each of these boxes in the Punnett square, you'll see that the whole square itself is 4 by 4, so there are 16 boxes, and this means that there are also 16 different genotypes, and these genotypes are what correspond or make up a certain phenotype or the physical expression of the gene. So now that we have our Punnett square filled out, we'll now move into the phenotypic and genotypic ratios for this problem. So now we have the phenotypic ratio, and one nice thing is when you're doing a dihybrid cross, you always end up with this 9:3 to 3:1 ratio. And so you see that I have the 9 tall and purple plants, the 3 short and purple plants, the 3 tall white purple plants, and 1 short and white pea plant. And so what you'll see is below each of these I have the genotypes for the specific phenotype that corresponds. So you can go back through your Punnett square and count up to make sure that this is actually the way it should turn out, which it is. So lastly, the genotypic ratio, or the count for each of these genotypes, ends up being 1 to 2 to 2 to 4 to 1 to 2 to 1 to 2 to 1. So I hope this has helped you understand a little bit better about the dihybrid cross. If you have any questions, feel free to comment below and I'll try to get to them as soon as I can, and look out for more videos. Thanks for watching.